Today we are going to look at an electrolytic cells. As we said that in our previous lesson, we looked at a galvanic cell. Today we are going to look at an electrolytic cells. As we said that in our previous lesson, we looked at a galvanic cell. Today we are going to look at an electrolytic cells. As we said that in our previous lesson, we looked at a galvanic cell. Today we are going to look at an electrolytic cells. As we said that are undergone or undertaken by the electrolytic cells. Now let's look at the lesson objectives. We need to understand the process of reaction taking place in an electrolytic cell. We also need to describe the movement of ions in the solution electrolytic cells. State the direction of electrons in terms of the flow of electrons on the external circuit. I think by now we understand the difference between an external circuit and the internal circuit. Also, write down the half reactions that take place of the anode and the cathode. Exactly as we did in our galvanic cell, we are still going to be expected to write the half reactions that occur to the anode and the cathode. We also write the overall cell reaction. We can also say the net cell reactions. Whereby we are going to combine the two half reactions to make one cell. The half reactions that occur. Now, you also required to describe using the half reactions, the equations for the overall cell reaction as well as the layout of the particular cell using schematic diagrams. Also discuss the following processes, which are going to be the processes that are undertaken by different electrolytic cells. This is going to be the decomposition of copper chloride, as well as the understand that not only the decomposition of copper chloride that can be examinable, there can be other compounds that can be separated, and we are expected to understand the decomposition process. Therefore, let's just say we are going to look at the decomposition process. We are going to look at the electroplating and also refining of copper, or we can say also purification of copper from the copper or from the crude copper. And also look at the electrolysis of concentrated sodium chloride, and it's used in the chloroalkali industry. Now let's look at what is this electrolytic cell. An electrolytic cell, as stated on the exam guideline, is a cell that converts electrical energy to chemical energy. The only difference between the two cells is the energy conversion. So you need to know what type of energy conversion occurs in each and every electrochemical cell. So in this case, we are going to look at a cell where we are going to use electrical energy to form chemical energy. And the next thing that you need to understand about electrochemical cells is that they are non-spontaneous. We saw in our previous lesson that our galvanic cells were spontaneous. They were occurring on their own without any energy added for them to react. However, these ones are non-spontaneous, meaning that they need electrical energy or heat to occur. And they are also endothermic reaction. Endothermic reaction because we're gonna add energy for these reactions to occur. So you need to know that they are converting electrical energy to chemical energy, and also there are non-spontaneous reactions, and there are endothermic reactions. So this is how we can describe, or we can try to understand, those electrolytic cells. Now this is just a simple schematic diagram just to see how does an electrolytic cell look like, or how can you build an electrolytic cell. You will need a power source. We can say a battery, or we can say a power source. Remember, the power source will provide energy to the cell. So now what will drive the electrons, or what will make the cell to operate, is the power source that is going to be one of the energy that is going to be supplied to our electrolytic cell. You will also have your electrolyte, and you are going to put your electrodes inside your electrolyte. Now, as you can see that our external circuit now, it is still formed by the electrodes and the wire, but remember now we are also including the battery. So we are going to connect our electrodes now. One of the electrodes will be connected on the positive terminal of the battery, and the other electrode will be connected on the negative terminal of the battery. Remember that when we were dealing with the galvanic cell, we never connected our electrodes, but our electrodes became a negative electrode and a positive electrode. So now what we are doing, we are directing, or we are giving charges to our electrode to say you must be positively charged and you must be negatively charged. So the electrode whereby we are going to connect it on the positive terminal of the cell is going to be our anode, and the one that we are going to connect on the negative terminal of our cell is going to be our cathode. Now we remember that what type of reaction occurs at the anode and what type of a reaction occurs at the cathode, which is going to be the same also in an electrolytic cell, because our anode will still undergo oxidation. So we are still expecting oxidation to occur at the anode and reduction to occur at the cathode. But what you need to understand now is that our anode will be connected at the positive terminal and our cathode will be connected at the negative terminal. As I said, that this electrolytic cell are cells that uses electricity to drive a non-spontaneous reaction. Remember, the reaction will be based on the energy that you are going to get from our power source. And also you need to know that an electrolytic cell is activated by applying electrical potential across the electrodes to force the internal chemical reaction, whereby there will be ions, and also which is going to be our electrolyte solution. Remember that our electrolyte is that ionic solution that conducts electricity. So therefore we are going to have ions conduct electricity. So we are going to have ions moving inside our electrolyte. But remember now, what will cause the entire reaction is the energy provided by the cell. We are also going to look at the process of electrolysis, whereby we are saying electrolysis is a chemical process in which electrical energy is converted to chemical energy. If you can look at the definition of electrolysis, you can see that it also obeys the definition or the energy conversion of an electrolytic cell. So we are going to look at the chemical reactions whereby those electrical energy is converted to chemical energy. We have two electrodes, as you have seen our schematic diagram. These electrodes will be inside our electrolytes, and there will be a power source. Now our power source, what type of power source do we need for our electrolytic cell? We need to know that we need DC current, we need direct current for our power source, because we want our electrons to travel in one direction, meaning that they must travel from the side of oxidation to the side of reduction. Because we remember that according to our Leo-Gay that we did last week, Leo-Gay, when you talk about the loss of electrons, you talk about oxidation. And also, when you talk about gain of electrons, you talk about reduction. So that is the main reason why we need to use a power source in order, or a DC power source, in order for our electrons to travel in one direction. We have already talked about the definition of an electrolyte, which is also going to be our solutions that we are going to use also in our electrolytic cell, and our electrodes, which are our solid electrical conductors that will make sure that they allow the movement of electrons from one side of the cell to another. Now, our electrolytes, as we know, that they contain ions, and those ions are the positive ions and the negative ions. Our positive ions are referred to as cations, and our negative ions are referred to as anions. You need to know that for an electrolyte to exist, definitely we need those positive and negative ions to be included in as part of the solution. Therefore, we are going to use our electrodes as our electrical conductors. We need to make sure that those electrodes can allow the movement of electrons from one part of the cell to another. So we normally use metals or carbon as part of our electrodes in our electrolytic cell. And we are saying we are connecting our electrodes in a power source, which is a DC or direct current source, whereby we make one of the electrode to be positively charged and the other electrode to be negatively charged. So all this is what we are going to be able to identify our electrolytic cell with. We are going to see if there is a power source in your cell. You will definitely know that that is your electrolytic cell. And also, we are going to have one electrolyte, unlike in a galvanic cell where we had two electrolytes. In our electrolytic cell, we'll only have one electrolyte, meaning that both the anode and the cathode will be inside one electrolyte where the ions will be transferred. Now let's look at the processes. As I said, that there will be 4 processes that we are going to discuss under electrolytic cell. So what is important is that you need to know how does each process occur, and under each process you need to know what physical changes will occur or what also chemical changes will occur. So we are going to look at both the physical and the chemical change of each and every process. Our first process that we are going to talk about, we are going to talk about the decomposition process of a compound. I am saying of a compound because it will depend on which compound are we going to decompose. However, for the sake of this lesson, I'm going to use our compound as copper 2 chloride. So we are going to decompose a copper chloride, and we are going to see what type of reactions occurs when copper chloride is being decomposed using electricity or in terms of electrolysis. So we are going to look at the separation of a compound, and we are going to use electric current to do that. As I said, that when you decompose a compound, you are separating a compound into its original atoms. So we need to see copper forming and also chlorine gas forming as we are going to look at the decomposition of copper. Now let's look at the schematic diagram, or the diagram in which we can use to decompose copper chloride into copper and chlorine gas. If you can look at the diagram, that we are having our electrolyte, which is copper chloride, and both our anode and cathode, they are inside the electrolyte. As I said, that we are using only one electrolyte when we are dealing with an electrolytic cell. So we can see that this is our positive electrode. Already we know that if it is connected at the positive terminal, it's going to be our anode. And this is going to be our cathode because it's connected at the negative terminal. So both our electrodes are inert, meaning that because what you want to separate is the electrolyte, you need not to have an active electrode that will produce ions or that will undergo oxidation in your reaction. So we normally use carbon as our electrode. So for the decomposition process, both our electrodes, we can use both our electrodes as carbon, but you know that one of the electrodes will be positively charged and the other electrode will be negatively charged. The only thing we want to separate copper and chlorine from the solution of copper chloride. So as you can see from the diagram, at the anode side, there will be some bubbles forming to show that there will be a gas formed. And we know that which gas is going to be formed when we do the decomposition reaction of copper chloride. So you will see that where there will be a gas formed, it means chlorine gas is formed. So what type of reaction you will find at the anode? At the anode side, you will see that two chloride ion, which are aqueous, they will undergo oxidation and form chlorine gas plus 2 electrons. So chlorine gas is formed at the side of the anode because a chloride ion, which is our negative ion, undergone oxidation by losing an extra electron. And when it loses an extra electron, it becomes chlorine gas. So you can see that the oxidation number moves from -1 to 0, which show an increase in oxidation number, exactly as we are looking at the increase in oxidation number and the decrease in oxidation number when we're looking at the galvanic cell. So because there's an increase in oxidation number, we can conclude to say this is our oxidation half reaction. So because chlorine gas now is formed, it is an indication that we have separated a copper chloride electrolyte we have separated it into copper and chlorine gas. And then at the side where there will be reduction, we will see that the copper 2 plus ions inside the solution, they will gain electrons. Remember, electrons are coming from the anode side. So they will gain electrons, and after gaining electrons, they will form what? Copper. And what is going to happen physically? We are going to see the color of the carbon electrode changing from black because it was carbon, and there will be a brownish substance that is formed on top of that electrode to show that this copper atom is being formed at the site of reduction. So these are the two reactions that will occur when we decompose copper chloride. Is our reduction reaction that will be undergone by a copper 2 plus ion, and our oxidation half reaction that will be undergone by the chloride ion. Now, we need to know exactly what is happening, and we need to explain also what are we going to observe as part of the observations that will occur in that process. So we can see that chloride ions were attracted at the positive electrode. Remember, chloride ions are negative ions. So definitely they will be attracted at the positive electrode. And as they are attracted at the positive electrode, our positive electrode, remember, is our anode. So therefore, it means our chloride ion will undergo oxidation and do what? And lose electrons. What will happen to the electrons that they will lose? It means now, when they lose electrons, those electrons will go to the reduction side. And what is going to be observed physically, you'll observe bubbles forming at the anode to show that chlorine gas is formed. And also, you need to know that the mass of the anode will remain constant because our carbon is going to be our inert electrode, meaning that it is not the electrode that undergoes oxidation, but the function of the carbon is to say, after a chloride ion has lost electrons, those electrons will be transferred to the other side of the reaction. Therefore, it means that our carbon will never undergo oxidation, but it will be an electrical conductor that will be used to transfer electrons from the site of oxidation to the site of reduction. So that is why the mass of the anode remains the same. It doesn't change. So a chloride ion will be oxidized to chlorine gas. So what do we expect to happen? So we know that when we say it's oxidized, we mean the oxidation number of chloride ion will increase, because we've seen that chloride ion undergone oxidation and formed chlorine gas. Then what will happen at the reduction site? Remember, what is also inside the electrolyte is our copper 2+ ions, which are blue in color. Because what we expect to see, we know that the color of copper 2 chloride is blue. What makes the color of copper electrolyte to be blue is because of the presence of copper 2+ ions. Remember, it's not just any copper ion that will make the color to be blue, but only copper 2+ ions are the ones that make the entire color of the copper 2+ to be blue. Therefore, when we undergo reduction, it means now we are going to use the copper 2+ ions as they are going to gain the electrons that are coming from the oxidation side, that are coming from the chloride ion side. And as they are gaining those electrons, they are going to be reduced to copper, meaning that there will be a copper solid forming at the site of reduction. So a brownish substance that is seen covering or coating the electrode where reduction will occur is because of the copper being deposited on top of that electrode. So physically, what you are going to see, you are going to see that the color of brown being forming at the cathode side. And because now we are forming an atom which is copper, definitely we will expect the mass of the cathode to increase because copper atom is formed. Even though a chloride ion side, there was no mass increase on the electrode because the electrode was not actively undergoing oxidation. However, at the cathode side, we expect the mass of the cathode to increase because copper atom is forming on top of the cathode. So what is going to happen is that the copper 2+ ion will gain electrons according to the reduction process, and those copper ions will be reduced to copper atom. So the process whereby we are going to see is going to be copper 2+, which is our aqueous, gaining 2 electrons from the chloride ion and produce what? Copper solid, which this is going to be our reduction half reaction. So because copper is formed and on the other side chlorine gas was formed, we can conclude to say we have separated or we have decomposed the solution of copper to chloride. So this is just a summary of our reactions that will occur when we decompose copper to chloride. We expect a chloride ion to undergo oxidation and form chlorine gas plus 2 electrons. At the reduction side, we expect copper 2+ ion to undergo reduction and gain electrons and form copper. So both copper and chlorine gas will be formed during this process of the decomposition. Therefore, what you find at the anode, you will find some bubbles forming to show that chlorine gas is being formed, and at the cathode you will find a brownish substance forming to show that copper atom has been formed. And also we expect the concentration of the electrolyte, which is the concentration of copper 2 plus copper 2 chloride, to decrease. What makes the concentration to decrease? And how are you going to observe that the concentration has decreased? You are going to observe by the change in color. So what will happen is that the color will change from blue to colorless. And when we are seeing the color becoming colorless or fading, it is an indication that now the copper 2 plus ions from the solution are changing, or they are gaining electrons and they're becoming a copper. So it means as the copper 2 plus ions are gaining electrons, it means it will be our oxidizing agent. Remember, we said a substance that gains electrons is our oxidizing agent, and in this case our chloride ion will be our reducing agent. So we know that both our oxidizing agent and our reducing agents are those agents that transfer electrons to each other. Therefore, that is why it is also very important to identify which agent is oxidizing agent and which agent is a reducing agent. So therefore, we'll expect our oxidizing agent to be reduced to copper because our oxidizing agent will undergo reduction. Therefore, this is just a summary of what will definitely occur when we are doing decomposition of copper chloride. So I have explained what happens at the anode side. I have explained what happened at the cathode side. So therefore, when they look for the physical observations, definitely we cannot talk about the gain of electrons because you are not going to be able to see the gaining of electrons. But what you can observe physically, you can observe bubbles forming to show that the gas is forming. You can observe the cathode being coated by a brownish substance to show that copper is being formed. And we will also observe the concentration of copper 2 plus of copper chloride fading or becoming colorless to show that also copper 2 plus are moving away from the solution and they are gaining electrons and they are forming copper. So this is the first process that we are going to look at, which looks at the decomposition of copper 2 chloride. Now the second process that we are going to talk about is the process of refining of copper. We can say refining or we can say purification of copper. So copper is widely used to make electrical wiring, and it is also used in application of high electricity conductivity. So we know that we use copper wires to conduct electricity. Therefore, the copper that we mine, or the copper that is the original copper, which is our crude copper, is not suitable for our electrical conductivity because there are impurities that will reduce the metal's conductivity. So the reason why we are purifying copper is to make it being able to undergo electrical conductivity by removing the impurities from it. Therefore, we need to make sure that we purify copper also by undergoing the refining process, where electricity also will be used to purify copper from the crude copper. So we'll expect also to have our electrodes. We'll also expect to have our impure copper, which is going to be our anode, and we are going to also expect the reduction side where we are going to form our pure copper. So as we have seen from the electrolysis of copper chloride or the decomposition process of copper chloride, for us to form copper, we will definitely need the ions of copper to undergo reduction and be reduced to pure copper. Therefore, it means we'll also need the electrolyte that will have copper 2 plus ions that will be able to gain electrons and form copper. And where will our copper be formed? Our pure copper will be formed at the cathode side, exactly as the pure copper or copper forming at the cathode side during our decomposition process. So when you look at the refining process, you will see that I have impure metal or I have impure copper at the anode side. Why is it impure? There are other ions that are on this copper metal. Therefore, we regard to it as impure. We also got an anode or cathode of the cell. Give a reason for your answer. Remember, we know that chromium will be the one that will undergo oxidation because we need it to coat our ring. Therefore, we'll expect our chromium to be our anode because it must undergo what? It must undergo oxidation and form chromium 3+ ion. The reason is because chromium must undergo oxidation reaction because it's the one that we want to use to coat our ring. So the reason why chromium is our anode is because it must undergo oxidation. And then write down the half reaction that takes place at the ring. Remember, we don't even have the half reaction of a ring on our standard potential table. The only thing that we know is that how will the ring be coated. So the process that will occur at the ring, we expect it to be what? To be reduction. So we'll expect the chromium 3+ ions to gain electrons and what? And coat our ring. So what is going to happen is that we'll expect Cr3+ undergoing reduction reaction and forming what? Chromium solid. So obviously the metal chromium will be formed on top of our ring. Therefore, that is why we are saying at the ring half cell we are going to have our reduction reaction. And the last one say calculate the total charge transferred when the mass of the pure chromium changes by 2 grams. So we are also going to expect or to be expected to use what? To use stoichiometric calculations in order for us to solve the calculations on this very important topic. So what you can see here is that we are given the definition of the electrolyte, which is an aqueous solution that is containing ions or substance that dissolve in water to give solution that conducts electricity. Any of this definition can be used in order for us to be able to get the 2 marks. Then we said our anode is our chromium because it is the one that is going to be oxidized or is where oxidation will take place. So we expect that our chromium must lose electrons and we expect the mass of the chromium to decrease because remember, as it is the one that will lose, we will undergo oxidation, we expect its mass to decrease. So therefore, our chromium will undergo oxidation and is our anode. And then the type of reaction that is happening at the anode is definitely the one that is chromium undergoing oxidation and forming chromium ion. So what is our reduction reaction at the ring? Remember, this is the reaction that will occur at the ring side. Chromium 3+ undergoing reduction and gaining 3 electrons and forming chromium. So this is our reduction reaction. It is very important that you know how to write your half reaction. Remember, we use 1 arrow. We start with our with our oxidizing agent, gaining electrons and forming our metal or our reducing agent. So as we can see that these are some of the options whereby, but we are not going to look at the options because we need to know how exactly do you write your oxidation and your reduction half reaction. You will still copy them from the reduction potential table and write oxidation from the reducing side to the oxidizing side and your reduction from the oxidizing side of the reaction to the reducing side of the. So you will write, we normally say we write them like C because oxidation will be going like this. We'll be starting from the reducing agent and ending up with the oxidizing agent, and our reduction will be from the oxidizing agent. So we are using 1 arrow because remember these reactions occur in 1 direction. And in our stoichiometric calculation, Remember, whenever you are doing a calculation, you must always remember that you are going to include what? The units. This is another option that we can use, which is not a problem. We can use both options for us to calculate the charge. Now let's look at this other activity. We are having a high purity copper is obtained by electrolysis of using a thin pure copper cathode and an acidified solution of copper sulfate. Now we are now looking at the purification of copper. Remember, in terms of the purification of copper, you also need to remember where are you going to connect the impure copper and where will the pure copper be formed. And also you need to remember that you also need the ions of copper that will undergo reduction in order to form copper metal. So already we have electrode A and B, and we have our power source. Remember, the long one, the long line represent our anode. Is our anode. Let me just write it nicely. Anode. And the short line is our cathode. And we are having a copper sulfate as our electrolyte that will contain what? That will contain copper 2+ ions. Now, already we know that this is our cathode and this is our anode. So our anode will definitely undergo oxidation. And at our anode, that is where we find our impure copper. And our cathode is where we are going to find that is where our pure copper will be formed. So these are the impurities because of the dissolving of the impure copper, which is our anode. At which electrode would the pure copper be deposited? Already they say choose from A and B. It cannot be like you are just choosing A or B. You must know whether A is an anode or cathode or B is a anode or cathode. And you know that where you are gonna find your pure copper is at the cathode side. So we expect our cathode to form at A, where there will be what? There will be reduction reaction. And write down the reduction half reaction. So remember, what we are going to what is going to happen is that the copper 2+ ions from the solution will gain electrons and form what? And form copper metal. And we expect the mass of A to do what? To increase, because it's the one that is the one where copper or pure copper will be deposited to. So before you can start looking at the questions, I think it is very important that you look at the diagram and try to analyze the diagram first. The next question, the copper sulfate solution or the copper sulfate electrolyte concentration remains constant. And we expect definitely the concentration to remain constant because we know that the copper, which is our impure copper, will undergo oxidation and form copper 2+ plus 2 electrons. And the copper 2+ electrons will undergo reduction and form copper. So our copper 2+ ions are becoming our product and our reactant ion. So the reason why the solution electrolyte remains constant, or the concentration of the electrolyte remains constant, is because the rate of oxidation is equals to the rate of reduction. And also here they say define an electrolyte. Just like the previous question that you did, you can see how important are the definition, and it's 2 marks. And then explain why the concentration of the electrolyte remains constant. As we said, the rate of oxidation is equals to the rate of reduction. Let's look at the options. We have seen that at A, that's where we are going to find our reduction reaction. And the reduction reaction that is going to happen is copper 2+ undergoing reduction and forming copper. So we expect the electrolyte concentration to remain constant because the rate of oxidation is equals to the rate of reduction. And this is the definition or the explanation of the electrolyte. Now here is another diagram. Let's look at the simplified diagram below. The simplified diagram below shows an electrolytic cell used to electroplate at the electroplating company to coat iron metals with what? With silver. So what do we want to coat? We want to coat these iron metals. Now the first thing is, where are we going to connect our iron metal? We expect to connect our iron metal at the cathode because that's where reduction will occur, and that's where we are going to find our pure substance. And then we expect our electrolyte to undergo what? oxidation. Now, because we want to coat with silver, it means where oxidation will occur, we must find our silver. And because we are coating with silver, we must also have what? Silver ions inside our electrolyte. So our electrolyte, even though it's not said to be silver electrode or what, we need to know that our electrolyte must have silver ions, because we want to reduce those silver ions to silver so that it can coat our iron metal. So the ion is not important because it will not undergo any reaction. It's the one that will be coated is our object. So already after understanding that what is the process that is going to happen, then you can immediately see that it means this is going to be your anode, and definitely this is going to be your cathode. So let's look at the questions. Write down the energy conversion that takes place in this cell. The energy conversion, remember, because of the power source, it is already telling us that it's an electrolytic cell. So we will know that this energy that we are getting or that we are adding in this process will make us to move from electrical energy to chemical energy. So the energy conversion, we expect electrical energy to be converted to chemical energy. And the reason is because we are having our power source as evidence that this is an electrolytic cell. What physical changes take place at electrode Y when the cell is in operation? Definitely, as electrode Y, we've identified it as our anode. We expect that it will undergo oxidation, and the mass of electrode Y will do what? Will decrease, because it is dissolving into the solution when it is forming the ions. So we expect the mass of this electrode to decrease. We cannot say it is losing electrons because physically we cannot see electrons being lost, but physically we can see the mass decreasing, or we can also see color changes where possible. But in this case, no color is going to change, but only the mass of this electrode Y will decrease. So which type of reaction will occur at electrode Y? We expect oxidation to occur at electrode Y. And also write down the balance or the half reaction that takes place at the iron metal. Now remember, at the iron metal, because that's where we are finding our reduction reaction, we'll expect the silver ions from the solution to gain electron and give us what? And give us silver that will coat our iron metal. So this is the reduction reaction that will occur at the site of the iron metal. Now, name or formula of the electrolyte X. Remember, our electrolyte X was not provided to us. We need to know that now, because we need the silver ions to undergo reduction reaction and form silver. So it means our electrolyte, we can have silver nitrate, we can have silver ethanoate, or you can just write Ag plus to show that you need silver ions as part of your electrolyte. Give a reason why the concentration of the electrolyte X remains constant. I can see that this question is coming now and time and again. So it means it is very important to know what will happen in each and every process in terms of the concentration of the electrolyte. And here the examiner is telling you that the concentration of the electrolyte will not change, showing that the rate of oxidation is going to be equal to the rate of reduction, or the reactant ions as they are produced, the product ions as they are produced, they are also being used. So it means you will find that both the ions are not used up in the reaction. So this is the energy conversion according to the expectation of an electrolytic cell, electrical energy to chemical energy. We expect the mass of the electrode Y to decrease, or the size of electrode Y to decrease, or the electrode Y is getting used up, or there's an erosion of electrode Y. And then we know that electrode Y undergoes oxidation, and at the iron metal there will be a reduction reaction whereby our silver ion as our oxidizing agent will undergo reduction by gaining electrons and forming silver, and what the silver that will be formed will be deposited on top of our iron metal and make the iron metal to look silver. And this is our electrolyte. We can use silver nitrate, we can use silver in ethanoate. The examiner was expecting us to write the name or formula. So both name or formula of this electrolyte are acceptable. Or you can just indicate that you must have silver ions, because they're the ones that are very important in our electrolyte, because they're the ones that are going to gain electrons and form silver. And the reason why the electrolyte remain constant is because the rate of oxidation is equal to the rate of reduction, or reduction and oxidation takes place simultaneously. Also, this one is another process of electroplating. So what are we electroplating? They say the simplified diagram below represents an electrolytic cell used to electroplate a copper coin with silver. So exactly what happened in our previous example or in our previous activity will definitely occur in this activity. What we expect our copper to be coated with what? With silver. So obviously, because we want to coat our copper will be our cathode, and our silver metal will be our anode. And the only process that is happening is a process of silver undergoing oxidation, because silver is a reducing agent, and silver ion undergoing reduction, because silver ions are oxidizing agent. Remember, the copper coin is not important also in this process, because it's the one that will be coated at the end. So we are expecting that we have our electrolyte, and definitely our electrolyte must have what? Silver ions, because they're the ones that must be reduced to silver. They're the ones that must undergo reduction and form silver. So the first question is, they define the term electrolysis, which we know that is the chemical process whereby the electrical energy is converted to chemical energy. So also here, as I said, that record those definitions at your spare time, go through the definition and see whether you can memorize them. Which component in the diagram indicates that this is an electrolytic cell? So what makes us to be convinced that it's an electrolytic cell is because of the DC power source or the battery. So the battery is an evidence that this is an electrolytic cell, because we know that that electrical energy will be converted to chemical energy. Name or formula of the electrolyte. This also comes for the second time, as you can see. It means we need to definitely be able to identify the electrolyte that will be responsible to undergo reduction in terms of the electroplating. So we know that we can use silver ions, or we can use silver nitrate or silver ethanoate, just like the examples that we got on our previous example. How will the concentration of the electrolyte change during electroplating? Choose from increase, decrease, or remain the same, and also give a reason for your answer. I think you can see also that in terms of the concentration of the electrolyte, all our questions normally want what will happen to the electrolyte, because we need to explain the processes in full. So what will happen? Remember, during electroplating, we expect the concentration of the electrolyte to remain the same. Why? Because as the silver atom is gonna undergo oxidation, it will form silver ions. And the silver ions that are being formed are gonna undergo reduction and form silver. So you can see that in both half reactions, silver ions are present, showing that the rate of oxidation is equal to the rate of reduction. As we are using up silver ions, we are also producing them. So that is why, as a reason, the rate of oxidation is equal to the rate of reduction, or oxidation and reduction occurs simultaneously. And then write down the balanced equation for the half reaction that takes place at the silver electrode. Definitely at the silver electrode, we expect silver, our metal, to undergo oxidation and lose electrons and form what? And form silver ions. So this is going to be our oxidation half reaction that will occur at the silver electrode. And this one, even though it was not us, is going to be our reduction reaction. So these are the expectations. We have given the definition of electrolysis. We know that the power source or battery is the one that is an indication that is an electrolytic cell. The silver ions or the silver nitrate or the silver ethanoate can be a suitable electrolyte for our reaction or for our electroplating process. We said the concentration remains the same because the rate of oxidation is equals to the rate of reduction. And at the silver electrode, we'll expect silver to undergo oxidation and form silver ion and electrode. Now, when you look at this one, you can see that now this activity involves two processes, and these two processes were asked at the same time. So that is why you need to know all the processes that we've discussed, and you need to know what is happening in each and every process. Because by mere looking, you can see that both processes are having power source, which is an indication that both cells are our electrolytic cell. So what I can advise you to do, before you look at the question, just try and analyze the diagram that you are given, and also gather as many facts as possible about the diagram or the process that is being asked on that specific diagram or question. Here they are saying two different cells A and B are shown in the diagram below. Cell A contains concentrated sodium. So this is this concentrated sodium chloride cell. Now, what is it that you know about the electrolysis of concentrated sodium chloride? Already, we have discussed the oxidation process and the reduction process in that cell. So even here, you will remember what is oxidation and reduction process that will occur at the sodium chloride half cell. And cell B, it says it contains concentrated solution of copper chloride. So already we are given cell B, which we are told that there is copper chloride that is in our electrolyte. But we don't know what process is cell B. So they're saying P, Q, R, and S are identical carbon electrodes. Remember, our carbon electrode, we said they are our inert electrodes. So already you can just recall what type of process or where we had our two inert electrodes in both our anode and our cathode, and that was a decomposition process, because it means our carbon electrodes will not undergo oxidation. So it means this one is the decomposition process of copper 2 chloride, and this one is the electrolysis process, or they can also be called electrolysis. Both of them, they can also be called electrolysis because we are separating a compound into its original atoms. So what do you know about cell A? You know that inside this cell there is water, there's sodium ions, there are chloride ions, there are hydroxide ions. So already you know that if it must be an oxidation, it will be the chloride ion undergoing oxidation and forming chlorine gas plus 2 electrons. So obviously you will expect chlorine gas, I'm not sure whether at P or at Q, but you'll expect one of the electrode to do what? To form a chlorine gas, where you're going to see chlorine gas bubbles. And then this side, one of the electrode must undergo reduction, one of the ions or substance must undergo reduction. And we said here water, because it's a stronger oxidizing agent, is the one that will undergo reduction and gain electrons and form what? And form hydrogen gas plus 2OH minus. So these are the two processes that we expect to occur where there is a concentrated sodium chloride, according to our revision. This side will expect what? We'll expect again chloride ion to undergo oxidation and form chlorine gas plus 2 electrons, and we expect copper 2 plus ions to undergo reduction and form what? Copper. So they are saying chlorine gas is formed at electrode P and S. So we expect electrode P and S to undergo oxidation because that's where chlorine gas is formed. So this is our anode, and this one is also our anode. So we expect P to undergo oxidation. At P, that is where oxidation will occur. or that is where we will find oxidation reaction. And also on the other side at S, that's where we'll find our oxidation reaction. So it means at P, that's where we are going to find our chloride half cell, and at S, that's where we are going to find our chloride half cell. Then this one is going to be our reduction half cell, and also this one is going to be our reduction half cell. Is the cell A electrolytic or galvanic? Give a reason for your answer. We expect the cell to be electrolytic, remember, because this is a cell with a power source. So a power source is an indication that this is an electrolytic cell. And then write down the equation for the half reaction that takes place at the electrode. Write down the equation for the half reaction taking place at electrode Q. Remember that it's just that is the Q is there. So we know that at Q, that's where water will undergo reduction and form hydrogen gas. So we'll expect hydrogen gas to form at Q because chlorine gas is forming at P. And then write down the name or symbol of the product formed at electrode R. Our electrode R, that's where copper will be formed. So at electrode R, we expect copper solid to be formed. And then what happens to the concentration of the electrolyte if the cell is in operation when cell B is in operation? So at cell B, that's where we are using copper 2+ ions and we are turning them to copper. So therefore, we expect the concentration of the electrolyte to decrease because the copper 2+ ions are reduced to what? Are reduced to copper. So as you can see that most of our questions are just repeating. As long as you know what is expected out of you, you will be able to answer any other question. Go through the whole processes, look at what changes occur in each process so that you can be able to answer the question. So the first one was the electrolytic cell, because we convert electrical energy to chemical energy, or because there is a power source. And then this was our reduction half reaction that occurred at electrode Q, whereby water is undergoing reduction and forming hydrogen gas. And then what will form at the other electrode where we are doing the decomposition of copper, which is electrode R, we are seeing that copper is going to be formed, or a brown substance is going to be formed to show that copper is formed. And the reason why the concentration of the electrolyte decreases is because the copper 2+ ions are reduced to copper. We have come to the end of our lesson. I hope you have gained a lot from this lesson, as I was encouraging you to look at each and every process and look at the changes of every process. Also remembering to write the oxidation and reduction processes of each lesson. Thank you so much for watching this lesson. Until next time, goodbye.